So here's the function of a ball thrown up in the air and the formula is given to you. So y equals 20x minus 4x squared is its height, y meters above the ground, x seconds after it's thrown. So complete a set of values from the height of the ball for the first 5 seconds. So that's 0, 1, 2, 3, 4, 5 seconds. Okay, so when x is 0, y is equal to 20 times 0 minus 4 times 0 squared, which is equal to 0. When x is 1 second, y is 20 times 1 minus 4 times 1 squared, which is equal to 16. So 1, 16. When x is 2, y is 20 times 2 minus 4 times 2 squared, which is equal to 24. 24. When x is 3, y is equal to 20 times 3 minus 4 times 3 squared, which is equal to 24 again. When x is 4, y is equal to 20 times 4 minus 4 times 4 squared, which is equal to, use your calculator, so 20 times 4 is equal to 16, so 4 and 16. And when x is 5, y is equal to 20 times 5 minus 4 times 5 squared, which is 0. So first 5 seconds, and there's your graph for the ball thrown up in the air. Okay, and now you want to draw the graph, so we need to get up as far as 24. So we have no minuses, so I'm going to have to go up maybe in 2s. So this is my x-axis, my y-axis labeled. So this is the height on the y-axis, and the x-axis has the time. So it starts with 0, 1 second, 2 seconds, 3, 4 and 5. Okay, and that's time in seconds. And up the height then we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So that's in meters, height in meters. So you have your graph drawn, or you have your points from the table above. So now you want to plot them. So 0, 0 is the first one. 1 goes up as far as 16. 2 goes up to 24. 3 goes up to 24. 4 up to 16. And 5 back to 0. So we're going to join these dots with a nice smooth curve. The ball goes up and comes back down. So that's the function y equal to 20x minus 4 times x squared. Label the axis x and y. Scale's the same each time, and that's how you get full marks in the exam. Now you're asked to answer a few questions based on the graph. So what's the maximum height reached by the ball? So the maximum height is equal to maybe 25 meters, because it goes slightly above the 24 to turn around to come back down. So somewhere between 24 and 25 meters. Okay. The 2 times when the ball is 2 meters above the ground, 12 meters above the ground. So where's 12 meters above the ground? get your ruler. So this is 12 meters. So what are the 2 times that it's 12 meters above the ground? So go down to your x-axis and read the time off. So part 2, the times are maybe 0.75 seconds and 4.25 seconds. So the 2 times height is equal to 12 meters. Okay, and the last part then, we want to find the length of time. It's above 15 meters. So this is 14, so 15 is about here. Okay, so how long is it above 15 meters? So everywhere here is above 15 meters. Okay, so what is the time above here? So that's from 1 second to 4 seconds. So part 3, from 1 second to 4 seconds gives you a total of 3 seconds above 15 meters. Okay, so that's a graph for you of a ball thrown up in the air. Okay, and the next one then, we have the graph of a function is 6x minus x squared. So this one represents the golf ball, and the golf ball is hit into the air. Okay, so x is 0 is the time it hits the ground, x equal to 6. Okay, so we're going to draw this graph. So when x is 0, 6 times 0 minus 0 squared is equal to 0, because my function f of x is 6x minus x squared. Okay, between 0 and 6. When x is 1, 6 times 1 minus 1 squared is 5, so 1, 5. When x is 2, 6 times 2 minus in brackets 2 squared is 8. When x is 3, 6 times 3 minus 3 squared is 9. Use your calculator for these, but you've had loads of practice by now. When x is 4, minus 4 squared is 8. When x is 5, 6 times 5 minus 5 squared is 5. 5, 5. And finally, when x is 6, 6 times 6 minus 6 squared is 0. So the point is 6 and 0. And again, we want to draw the graph. Okay, so there's no minuses again, which makes it easier for you. We want to get up as far as 9. So this is the x-axis, the y-axis, 2, 4, 6, 8, 10. So we've loads of room there for that. And that's going to be the height in meters. Okay, and below that then is the time in seconds. So in this case here we have 0, 1, 2, 3, 4, 5, and we need 6. Okay, so extend our graph and we have 6. So this is the x-axis. So again, plot your points. 0, 0, 1 up to 5, 2 up to 8, 3 up to 9, 4, 8, 5 up to 5, and 6, 0 again, which gives you a smooth curve like so. And that's your graph of f of x equals 6x minus x squared. Okay, now you're going to answer a few questions. So the first one, what's the greatest height reached by the golf ball? Greatest height is equal to 9 meters. Okay. What is the height of the ball after 1.5 seconds? So 1.5 seconds is somewhere here. So what's the height of the ball after 1.5 seconds? And go across. So I would say it's maybe part 2, 6.2 meters height. Okay. After how many seconds was the ball 10 meters above the ground? Now, this one you have to be careful with, okay? Because it says here, each unit on the y-axis is 5 meters. So 5 meters, 10 meters, 15 meters, 20 meters, 25, 30, 35, 40, 45, 50 meters. So how many seconds was the ball 10 meters above the ground? So this is 10 meters above the ground, and that's after 0.5 seconds. Okay, so part 3 is 0.5 seconds. How long does it take to reach the maximum height? So its maximum height is here. So part 4, it takes 3 seconds to reach maximum height. Okay, and that's your graphs drawn for today.